So sufficient statistic is another property for estimator. So actually, the concept for sufficient statistic, it relates to the amount of information it contains. So normally what we did before, we just give, let's say we have X bar, we have S square to express the whole observation in the sample set or in the data set, okay? So normally we define statistic Y or statistic T, okay? It's a sufficient statistic where we can compute the conditional probability distribution. So conditional probability distribution, that's mean you have your fx1, x2, xn here, okay? So given your family T, where your T is your sufficient statistic, so we express in terms of your conditional probability, so we get the joint PDF, okay, the joint PDF, and also divide by your PDF of your sufficient statistic. So that is based on definition. So once we get the ratio of this one is your function H. So your function H does not depend upon theta. So then we call T is a sufficient statistic for theta. Okay. So again, we already compute for Bernoulli trial or Bernoulli distribution. So we want to show that Y equals to summation Xi is a sufficient statistic. So the first example is based on definition. Okay. So based on definition, we compute the conditional probability. So that means we have to construct the joint PDF. Okay. So based on the joint PDF, we have theta to the power summation Si, 1 minus theta to the power n minus summation Si. And then we build up the joint probability. Okay. So in here, we have probability x1, x2, xn, and also t equals to t. So the last value, which is your xn, Sn is equals to t. So since our t is summation xi, so that means you have your xn is equals to t minus summation xi equals to 1 up to n minus 1. Okay, then we get back your xn. Okay, so we simplify since the random sample are independent, because in the concept for sufficient statistic, normally our data set is assumed to be independent, identically distributed. Okay, independent, that means you can multiply the probability. Identically distributed, that means we have the same distribution for each x1, x2 up to xn. Okay, once we simplify, okay, we get this value. So theta to the power t, 1 minus theta to the power n minus t. So we cancel out the value. Okay. So we construct the joint probability. So conditional probability distribution is given as your joint probability here. So divide by family of your sufficient statistic. So in this case, your probability distribution, the original distribution is Bernoulli. So once you have the summation Si, it will become binomial. So binomial, so this is your PDF for binomial. Okay, so cancel out, we just have 1 over n choose t. So this value does not depend on the parameter theta. So by the definition, your t equals to summation Si is a sufficient statistic. Okay, so that is based on definition. Okay, so we have two concepts. So this one, either you want to use definition to find the sufficient statistic. Okay, the other one, we use the factorization theorem. So based on the question, if the question want you to solve using definition, so that means you have to construct the conditional probability distribution and then find your PDF function for your sufficient statistic. Okay, normally the question is just show that, okay, not find